No. Can I borrow an eraser? I have like, no eraser. Wait, if I was like.
So far. Being hinted there, isn't there? I know it's gonna be on the side. I got one of the ones I got. Where I ran into Prius. Yeah. No, I think it's, oh no, it's I do the triangle, but you're right. That could be it. It just, if you don't draw it like to. It's like, right here. So, you know, how do you? Well. So then, yeah, we're just.
Oh, I'm saying that I post.
6 times, sorry.
It's something.
Yeah.
Right.
And then A also has two different
But it's
possibilities.
Yes.
Uh-oh.
That sounds.
180 minus 25 minus 40.
And it goes A2.
Which is.
Just
fine.
yay.
End of the day. Sorry.
So set up and come out.
Check in with your neighbor, make sure they're doing okay.
I
On the
just
path
did
of
the
success.
honor.
Done.
Yeah.
Yes.
Thank
You're not there yet.
19.7. Wait, which one is 2 for you? One was. One. Oh. Yeah. Because you do, this, A, or what, sorry, B2 plus, spot, because you can talk to these, and then you still have to 180 minus stuff. Because C1 is 25, C is always 25. Oh, C is, yeah, C is always 25. 110.
This.
Wait. 6 times.
That's what I. No.
Grandma.
Science law.
So
So I got the same.
you did the one you
One
did.
that's.
You just about done?
Wait, one more.
It's like maybe. 13.324.
This is like our.
Did you get that from another side? 13.324.
I got 13.322. You have to use the unrounded value. You can't just put it in like that.
Oh.
Did you get 13.3?
Wait, two?
Out of
Wait, I just put in the whole number unrounded.
Wait, first, oh, for 44, oh, I'm so sorry, wait.
Yes.
I got that.
They're just trying to like. It's easier.
Wait, I thought it's round though.
Yeah, but you can't, but you can round it on your paper, but you can't round it on your
No,
calculator.
if one.
Like that.
Yeah. It's logging.
13.322.
Oh, that's part of the system. Wait, and then you take
I
that
got-
points for like.
Yes.
prematurely?
Yeah.
Right, prematurely?
Like, cause someone got 30.
Like if you write it, like if I write it like this on my paper, but I should use the whole number in my calculator.
Cancel, but.
Yeah.
One minute. This is one.
Oh, okay, but
Wait.
I don't say I should.
No, that's fine.
Wait, so like if Sahana got 3.3, and I got or like, wait, yeah, 13.324, like.
Then I'm right
That
that
difference, like, yeah,
Right, the 3 decimal places.
yeah, but like if we have like different like decimal points. No,
I use the whole
wrong,
number.
but like, just like.
But she's saying if it's off by one decimal place, because
Yeah.
it's like, if you use using the full number versus not, and if it's off like the third decimal place, like, do you count that as well?
Yeah.
Okay, I'll make sure to not do that. No, I'm not.
You
I
get
think
partial
the tiniest,
Yeah.
yeah. Like,
Not that mean.
well, yeah, obviously not the whole problem.
Little mean,
But,
yeah.
like,
Yeah, I
the
got
tad,
it.
yeah.
A second B.
Yeah.
Yeah, you ready?
I'm just.
Let's do this, shall we? Okay, folks, let's talk about this. We have a lot to do today. We got to finish the section. But before we do that, the warm up. We've been given 2 sides and an angle. What case is this? We're going to be using law of sines.
Yeah.
And also the 2 sides and the angle is either SSA or SAS, isn't it? 2 sides and an angle. There's no other option. And there's no other option. So how do we determine what it is? Just by looking at it? Can we tell with, or do we have to draw it first? The fact that we have an opposite, right? C and C means we're dealing with this. Yes, Henry? Oh, it's frozen. I'm sorry. Thank you. Writing stuff. Following along. Sorry, we have either SSA or SAS. So the fact that we have C and C means we have one that's opposite from the other. In SAS, we don't have anything that's opposite from the other. If you have SAS, then you're going to use what to solve that triangle for SAS? That's law of cosines. But for SSA, we do use law of sines. And of course, in this case, you have to watch for ambiguous case. Are we good with that just like as an overview? And I did tell you. Well, like I said, we'll have 1 law of sines on the test. And I'm going over ambiguous case because I'd like to give you the most challenging type that I can. Just to make sure you're set. Is there a question? Yeah, hold it.
Oh, yeah. So you said when you were responding to a question, there's gonna be 1 law of science. Does that mean?
That's it.
Referring to just 1 question?
1 question of law of sines, yeah. Did you want more? Was that a request? I could ask.
Yes.
Oh, so yes. Oh, okay.
The one
It's
question.
like some,
The one.
yeah, not the whole test.
Crazy kids. Okay. So when you have the SSA, I do recommend you put your fixed angle in the lower left. It doesn't have to be, it could be wherever it is, wherever you want it to be, but I'm going to put this right here. So we have C degrees, and then this is 10 and C. I can make it a little bit longer. So it's going to be either this one or this one, right? That's a swing side. So using law of sines, you're going to be finding angle B first. Is that correct? Okay, so angle B is either going to be right for to here or here. So law of sines will get you which one of those? The one on the outside or the one on the inside? The one on the outside, right? It's going to give you this one. Law of sines. Ultimately, you have to use sine inverse, which will always result in an angle between, well, negative pi over 2 and pi over 2, but since we're not talking about standard position, it's an acute angle. So what I recommend doing is just draw two separate versions of it. See if I can do this. Move this over. Can I copy it? Can I do it? I think I could copy it. Copy. Can I paste? I don't know. This is. Ha! Okay, got it here. Save myself erasing digital marks. That's great. So then this is the other one. Here's my newbie. This is 6, I believe. Okay, so we're going to start with, I hope you listed the A, B, C. A, B, C. We know that C is 25 degrees. C is 6. B is 10. I think everything else is approximated. So in order to do this, next thing you're going to find is angle B, which is approximately 43.8, 44.8-ish. And for angles, and if you're using degrees, I want 1 degree or 1 decimal point accuracy. From there, you get your A, whatever that is, next, and then last. Yes? Pardon? I want you to be accurate on a test. So if you're writing something that's equal, use an equal sign. If it's an approximation, but use approximately equal to. Good question. These little things, the devil's in the details. The bridge between these two triangles is where? What's the key? Well, yeah, these have the same thing. So the bridge of information I need to make sure you can do is the angle B, correct? These two angles are supplementary. So once you have that 44.8, this one becomes 180 minus 44.8, whatever that is. And then you continue on with the information for the second triangle. Is it comfortable? Cool. Do I need to talk about the answers for A and B? For A's and A's? Okay, you should be able to do that on your own. If you're unable to do this, if it doesn't make sense, please make sure to get some help. I'm happy to help you. Or help one another. Any questions? Perhaps your question is, can we finish the unit, please, Mr. Lieberman? In which case, the answer is yes. Let's do it. Lydia, that's what you're asking in your brain, wasn't it, too? Just shy. You're shy, I know. So linear programming, it's a little bit labor intensive, I'm not going to lie, but it's steps you can follow. So this is what, page 11. Page 11. Linear just means the exponents are all going to be 1. And we're not going to have any x squared, x cubed, or anything like that. So it's linear. And programming, I'm not sure why it's called programming, is the truth. I'm sure there's a reason. Like companies use this to find ways to optimize or minimize expenses or profits or different factors based on their data. So here's a general process. 1, you would take a word problem, define variables, set up constraints, and an optimization equation. We'll walk you through 3 problems just like this today. 2, then we're going to graph the inequalities to determine a feasible region. Number 3, find corners of the feasible region to determine where extrema may occur. And extrema, that's just another way of saying maximum or minimums. And then evaluate the optimization equation at those corners to determine the best solution. Okay, so let's try example 10. Now, one issue with these problems is that there's a lot of information, so I know very often you try to do the problem immediately. Read it once for understanding. So I'll read it aloud while you read to yourselves. You need to buy some filing cabinets at your workplace. You can purchase cabinet X, which costs $10 per unit, requires 6 feet of space, of floor space, and holds 8 cubic feet of files. On the other hand, cabinet Y costs $20 per unit, requires 8 square feet of floor space, and holds 12 cubic feet of files. You have been given a budget of at most $140 by your supervisor for this project. The office has room for no more than 72 square feet of cabinets. How many of each model should you buy in order to maximize storage volume? Whew. That's a lot of information, isn't it? But fear not, we'll put it all together. First thing I'm going to do is I'm going to divide my place so I'll have my workspace, so I'll have enough information for everything. I'm going to cut it in one left side and then upper right and the lower right. Just general guidelines. It's always going to, in this class, it's going to be broken down into 2 different things. In this case, we're not trying to figure out floor space. We're not trying to figure out volume. We're trying to figure out how many of each cabinet to buy. Yes? So we're trying to figure out many of each cabinet to buy. So let's label our name our define our variables, excuse me. Let X equal number of cabinet X's cabinet A's, excuse me. No, it is cabinet X. And Y is equal to number of cabinet Y's. I should put an S on it and make plural. So from there, I'm actually going to skip to the end briefly. And I'm going to see what is it asking for? How many of each model should you buy in order to maximize storage volume? So I know here at the end, I'm going to have to put in some sort of volume equation. Just kind of trying to figure out what's going on. And now I'll just kind of summarize my information about cabinet X and cabinet Y. It tells me that cabinet X, $10 per unit, 6 square feet, and 8 cubic feet. Cabinet Y, $20. 8 square feet. And 12 cubic feet of files. So far, so good. Now that all this information, I'm going to go ahead and write what I'm trying to maximize. In other words, that volume. I think I have enough to make an equation for volume. Volume is equal to, does this make sense? At 8 times X. And then 12 times Y. Now what I have to do is use the other information to write what's called constraints on these quantities. There are things that are limiting. We can't have 1,000 of each cabinet to have maximum storage space. There's just not enough room in this office. So let's see what it says. Okay, so it tells us, reading this again, we've been given a budget of at most $140. You see what one of our constraints is going to be from that? Discuss with your neighbor. What's the constraint if you have 140 in the budget?
12 Wait. X 12 Y.
So I heard it. 10 X
Yeah.
plus 20y has to be
Less than or equal to.
less than or equal to 140. So one option is to buy 0. You'd be staying in your budget if you buy nothing. I imagine we want to maximize storage, so I don't know if we need a little bit more. Did you have another constraint? Yes, Kimmy? Are we good with that? Less than or equal to 72. Okay, so those are other reasons you can't just buy 100 of each. You have a budget, you have limited floor space. There are some implied constraints too. What was that? Yep, X has to be greater than or equal to 0 and Y has to be greater than or equal to 0. What are we going to do with all these inequalities now? Graph, So I'm just going to focus on the first quadrant because everything is positive. And what's a good way to graph that first inequality? Find the intercepts. I'm going to make a rough sketch, and if things get tight, maybe I'll make a more accurate sketch. But I found out that the x-intercept is 140, the y-intercept is 7. Is that clear? And maybe I'll put here cabinet X, just to reinforce that that's what we're talking about. Cabinet X, and this is cabinet Y. So let me see if I can connect those dots. We have this going to there. And the other equation, 6x plus 8y is less than or equal to 72. We could divide all that by 2, but really there's no need to. The x-intercept is that 12? Is that right? X-intercept is 12 for the second one? Okay, so that's a little bit less than 14. Is my math right? 12 is less than 14? Great. Okay. And my y-coordinate, my y-intercept? 9, which I believe is a little bit more than 7. Okay. Oh, I forgot to do the inequality part. So for the first one, I'm going to shade below. And the second one, I'm also going to shade below. So we see where the overlap is. Of course, that x is greater than or equal to 0, y is greater than or equal to 0 just keeps us in the first quadrant. So we're left with a shape that looks something like this. I don't know if you remember. I'll give you a chance to catch up to where I am here with your graphing and labeling. So according to linear programming, the maximums and minimums of that which we're trying to find, this volume, is found at the corners of the shaded region. So what we're going to do is evaluate how many corners? There are 4 corners. So I'm going to find V of 0, 0, V of 12, 0, V of 0, 7, and I have to find V of, you see what I have to find? Find this point of intersection. I'll give you a moment to work on that. You get all the values? So V of 12, 0. What'd you get? 12, 0? V of 0, 0 is 0. 96. Are we good with that? We're just plugging the 12 in for the X and the Y, 0 in for the Y. So it is 8 times 12, which is 96. The next one is going to be 0 plus 12 times 7, 84. And the last one is 8 times 8 plus 12 times 3, yes, which gives us 100. Now, there are a lot of different possibilities. We could have 1 of cabinet X, 1 of cabinet Y. You could have 5 of cabinet X and 2 of cabinet Y or something like that. But the maximums or minimums of the feasible region, those are the ones that are possible to get based on the constraints of those. This will include a maximum and minimum value. So since it's a word problem, I need a sentence answer. So to maximize something like this, storage space by 8 in cabinet X and 3 cabinet Y, something like that. Just make it clear that I know what you're talking about. Any questions? And when companies actually use this, business models use this, they have maybe hundreds of constraints that they're trying to put together to maximize a profit, minimize any sort of loss. But we're just starting simple here. A manufacturer of fridges must ship at least 100 fridges to 2 West Coast warehouses. Each warehouse holds a maximum of 100 fridges. Warehouse A holds 25 refrigerators already, and B has 20 on hand. It costs $12 to ship a fridge to warehouse A and $10 to ship to warehouse B. Union rules require that at least 300 workers have to be hired. Shipping a fridge to warehouse A requires 4 workers, while shipping a fridge to warehouse B requires 2 workers. Try to minimize the cost. Ton of information. Let's see if we can put this together. Your neighbor, make sure they're on the right track. And calling someone to give me a hand to get started here. So please make sure you're again checking with your neighbor.
Yeah.
Yes. 25, yeah, that makes sense. And then,
Oh, wait, it
it's
should
greater
be
than or
less
equal
than-
to your
It
right.
should be less than though, because it.
Oh,
It,
for 4x plus 2y. Or,
no,
oh,
these
no,
are be, because it can't hold more than.
yeah, so I'm just up that you're right.
Yeah. But I think there's only these three because it's, I think there's only like three. Versus whatever.
X y is less than or
That's
equal
worth
to
it.
80. What are you getting for the next system of the equation?
Right, like.
No, I think it's just this,
It's just
call
that.
that line, because it's
Oh.
it's already gonna have, like,
Right.
because it's already like this, it's not like 0, 0, 0, 0. I mean, I maybe I'm wrong.
Yeah. You're right.
Are you ready? Yeah, I'll call someone in about 15 seconds. Just tell us what they've done so far.
Like what the what?
What's that?
Oh, wait, what?
Just what they've done so far.
Oh, okay.
What's 300?
Okay, folks, the time has come. I want to hear from you. Christine, what have you done so far? How did you start on this problem?
The variable x is number of like British ship.
Okay, move to warehouse A. I'll call it WA. Okay. Warehouse B. Are we good with that? Okay. Do you want to go on to tell us anything else that you did or?
One of the constraints was that x, or actually x is less than equal to 100.
X is less than or equal to 100. And how do you know this?
Because each warehouse holds a maximum of 100 fridges.
Okay, nice. Okay. Anything else or it's about how far you took it?
Maybe the find the cost equation could
Mhm.
be both the response and
So the thing that we're trying to minimize or yeah, minimize. Okay. So I'm sorry, you said it's do we agree with that? Sounds good. Thank you, Christine. Okay, Amir. Did you get any further than this? Okay. So warehouse A, warehouse B. Warehouse is just too long for me to write, so. So it has 25. Okay. For warehouse A. Okay, 4 workers. Cool. So this one has 20 already. And this is 10 and 2 workers.
So,
One, four, plus two, for the 300.
I'll use X and Y since that's what we started, but yeah, it has to be. Do we agree with that? Does that make sense? Okay. Before we continue, did you want to continue? Okay, before we continue, let's hear what Sahana has to say.
So for the X is less than or equal to hundred and Y is less than or equal to hundred, I thought it was X is less than or equal to 75 because it already has 25 and there's a maximum of 100 bridges.
Should we adjust that? Because they can't send like 99. And they can't send 99. So to empty factories and empty warehouses, that would be appropriate. But for some reason, there's this extra information. So we'll make this one the 75, we'll make the other one 80. Okay. Cool. Thank you. So Amir, did you want to?
I don't know if this one's right, but 25 plus A plus 20 plus B. So,
Have to say. I think you're on the right track. You're on the right track. But who could kind of help him? Because this is the tough one. Who can help him with this one? How are we going to use that 100? Right? Because it says they have to ship 100. Are we good with that? Just X plus Y? That's the actual number that they're shipping. So we don't have to adjust anything, but it depends how you labeled your variables too. So X plus Y has to be greater than or equal to 100. Right, so I'm the manufacturer, I have to distribute to A and to B. It says up here, manufacturer must ship at least 100 bridges to 2 warehouses. That's what that is. Yeah. Were there any others?
There's never been a shift.
Yeah, ships too. You're right. Yeah, I was lazy there. I'm gonna amend the X is less than 75 to include also greater than 0. Same with the other one. Just to make sure we're not sending negative numbers of fridges anywhere. I hate when that happens. Did you already start graphing this? We have all the information we need. Or do we have all the information, or are there other constraints? I think we got the money. We got the workers. We dealt with yep, we dealt with everything else.
Yeah, one thing I'm going to.
I've never been.
I'm gonna love myself in math class Tuesday.
This is not eight, oh, wait, no, it's 81. It was 71. So this is the one.
Still looking about right? How many corners do we have? X equals 75, thank you. Yeah, less than 80. I need some help.
Why?
Yeah, I need to figure out something first. You find that point of intersection, so I have to know if it's like above it or below it. With my scales, I'm not a calculator, so. Yes, I know that 80 is below 100, but is it gonna be above this? I'm just not sure.
Oh,
It's just to be cautious.
it's 50 come.
50/50? Okay, thank you. That's super helpful. 50/50. Okay, which means we're gonna be like right here. I see below. So where's the region that we're talking about? How many vertices are there? Are there 4? Let's see, it's above the 2 slanted lines, right?
It's unbound.
That was like my,
But it has to be in that little that square, the rectangle, doesn't it?
never mind.
Has to be in there. So yeah, this is our region. All right, we can't send 100 to each. We can't send 1,000 to each. There's a limit based on storage capacity of each warehouse.
Can you give us like, grids or?
We'll probably give you a grid.
5, no, there's 4.
So this is 75, 80. This one here is, I know something, 80. This point here is 75, something. And 50/50. So you're checking all 4. Although for minimizing, I imagine that those 2 big numbers are going to be too large. I'll be calling someone to help me out with the rest of this in just a moment. Are we ready? Okay, give me a little bit more time. If you finish anyone, go on to the next one. Make sure to check yourself when you finish this. Are you appreciating the intercept method of graphing? Are you appreciating it? I hope so. So direct. When there's room. Okay, I need some help. Sophia, can you help me? I'm not sure what to do next.
I used the first one, 75.
Okay, okay. 1,700? Okay, thank you. Okay. Are we comfortable with these numbers, everybody? Like, we know where they're coming from? Yes. So the 50/50? Well, we need the vertices of that shaded region, so we have 50/50. Just from some algebra, putting these two together. Is that what your question is?
Yeah.
Yeah, so we had to find that point of intersection. Okay, Sophia, you want to continue?
Sorry. The one where I used the equation x equals 75.
Okay,
Y plus x equals 100 to find the intersection.
okay. Right, so if they add together to be 100. Great. Oh, and sorry, what did you get for 50/50? 1,100, did you say? Looks like erased somehow. Okay, and were you able to get values for 75/25? Okay. That was quick. 1150, thank you. 1150. And the last one. Sophia, did you do the last one already? Or okay. Who'd like to tell us remaining? Yeah, Eileen? 580. And that yields what kind of cost? 1,220. Cool. So we see our solution. I send 50 to each to minimize the shipping, the costs. Is that wrong? No? Is it wrong?
28 is the wrong region. If it would be if it's like that little triangle next to it.
20?
20 combination.
Oh, this one right here? Yeah, that's not feasible. That would be not enough,
Wrong ones.
So how I find the.
You use the line, of the 4x plus 2y is greater than 300. That, I think you use the other.
yeah, it looks like. Sophia, thank you for your help, by the way.
Yeah.
Trying to give you about 2.5 minutes to digest, zone out, stretch if you need to. Until 2:40.
It's that, so the.
I know.
Genuinely.
At least you late start tomorrow. Yeah. Mhm.
I'm actually the gods.
Yeah.
Like one night.
I finished it. The ending's really annoying.
Wait, you guys finish?
Yeah.
Like we're so
Dr. Long's like, run it.
we have like a we have our
Really? We have our creative writing after.
what?
Wait, she told us we don't have like a project plan.
We have a focus, but I don't
Oh, it's like.
So question. Is brought up, why don't we use this other vertex, this 20, 80? So, yeah, it's not in the region, so what's wrong with it though? Sahana,
It's like the line, is it the right one that's intersect? So you're not finding like the right point of intersection.
like we're finding the wrong point of intersection, so, but practically speaking, like in the context of this problem, what's wrong with 20, 80?
So,
Specifically, what's wrong with 20, 80? 20 to A and 80 to B? Because it's still 100 fridges, right? So what's wrong with it? So it's a problem with the workers, is that true? Let's see. It's how many workers for A? 4?
4, yeah.
That makes 80 and then
160.
160, so 80 plus 160.
240.
Okay, we need at least 300 workers, right? So that's not feasible. It's only things that are above, right? It's got to adhere to all of the constraints. All right, let's finish this up. Talk about money, shall we? Let's do it. Let you read it to yourselves. As I read to myself, the last of the unit.
I'm manifesting.
Discuss with your neighbor. What are you doing?
Or.
I give $300 for like $1 million. Do you know what I mean? Like it's $300 per person. Is that like normal? You know, like if you're investing
Yeah.
$1 million,
It's not bad, right?
right? Like
It's a small portion.
compared to that whole million. Yeah. I'm saying X is the number of fees.
No. It's, I think it's the amount of money invested in bonds though. Because the fees is something that it's based on the amount.
Oh, fact. Yeah.
Amount of money invested in bonds and amount of money invested in mutual. Okay.
I will be calling on someone to help me out with these. So make sure you're checking in with your neighbor, that everything's going well. No, just dollars. Less than $10,000. Right, so a little confusing with all the different quantities. Per million, yeah.
If you just write that for X and Y, it just.
Then it's gonna be 300x plus 100y.
It's, no, 300x plus 100y is less than, which is $840. That's the fees.
Or 8,400. No, never mind. I
Yeah,
was-
yeah. Plus y is, less
Less
than
than or equal to.
You don't have to write all because it's already in, I think. Maybe, wait,
So I just.
No, you do.
Are you sure?
yeah, because it's not like.
Less than or equal to.
No, actually. Yeah, but then this. Is weird because if this is in.
So much information to organize.
No, wait, no, this isn't. No, wait,
It
because.
does. It's just like for this equation, you have to write it out as like.
Yeah, but this times a million plus this times something a million would be less than or equal to 8,000.
Okay.
Wait, hold on, just so sport.
Oh, so is it just?
The GCI.
Yeah.
So.
Oh.
Oh, but you did it with the new stuff.
Yeah.
But that's. Right, it's like, no way.
Oh, okay. I'm just gonna.
Yeah, no, it's just, we got this, yeah.
Okay, I want to get started. Kimmy, can you give me some direction here, please?
I used B and M, I think most of you.
Okay, so you said let number of bonds. And it's number of, right? So number of mutual funds, okay.
I'd be false. No, so. B has to be greater than or equal to 20 million, and M has to be greater than or equal to 6 million.
So bonds and output MF here. So bonds, say that again.
20 million, M has to be greater than or equal to.
Sorry, 20 million?
20 million. M.
Okay. And these has to be greater than or equal to,
6.
or did I do this right? Is 6, is this right? Okay. Okay.
Plus 1. Has to be less than or equal to. Let's see.
Say that one more time, I'm sorry. Less than 8,400? Are we good with that, folks? Okay. I'm having a hard time hearing you, I'm sorry. B plus M is less than or equal to 50. Should I write million? Like, I'm not comfortable with writing letters when I'm writing numbers. How about we just say 20 and then 6 and 50 then, and all these units are million. Are we good? So is this 8,400 million then? So yeah, it's not. So I think we need to clean a little something up. Kimmy, this has been great so far, but just this one thing. One thing we need help with to clean this up just a little bit. Because we're not like purchasing one mutual fund or one bond. We are investing we can't say number of bonds. There's no like per cost. What's that? Cost or amount invested in bonds. I think which is basically the cost. Amount invested in bonds, and then at the same time we'll say in millions. So we don't have to write the mil after everything. And a similar thing for the next one. So amount invested in mutual funds in millions. Cool. Yeah, so the constraints perfect. Your all the information here perfect. Any other constraints? Did we graph it already? Was there a region where they all intersected? Cool. Oh, I need one more thing, don't I? Algebraically speaking, I need to have an equation that for B, and what is this? Interest. So maybe I'll do 0.04 B plus 0.06 M. The 4% of the amount put in bonds, 6% in the amount of mutual funds. Do you know why mutual funds would have more percent? Is that accurate? Do you know why that is? Why mutual funds would yield more? Mutual funds are based on the stock market. They could go up or down. There's an average price that they go up, or average interest rate that they go up. They might go down. Like recently, they've gone down. Bonds do not go down. They're fixed, yeah, no matter what. But you also have to hold on to them for 20 years or something like that. Or 10 years, depending on the bond. When you buy a bond, you are lending money to an organization like a country, then they pay you back later. I just want to know my points of my corners.
The triangle.
Whoa.
That's whoa,
I think.
Yeah, see, because there's the one.
I drew.
Like this triangle.
What? I can't.
Oh, wait.
There's no way I just.
Yeah.
Oh, what?
So remember what B stands for? Amount invested in bonds in millions. The B is 1. And that's the bonds. B is 2, that's 2 million, so that's 300 times 2 million.
I think we're okay. Do you really have an M-intercept of 84? Is that right? Okay. I'm not afraid. I'm not afraid. M-intercept 84. I'll put that up here because I don't think that one's going to be bigger than that. The B-intercept is 28. And then 50 and 50. Oh, and at least 20. What's the point of intersection? No, did you get it?
Got 26 cup 6.
Are we good with that? 26.6? I feel like they have to add up to 50, so that?
Because I'm looking for my region, so I want to do B is greater than 20. I don't know if 20 is over here or over here. So I just need to know for accuracy's sake where it is. Yeah, Shane,
I got 17,33.
1733. Thank you. Right, the way I'm doing it, I can't assume where the 20 is. But now I know that since that's 17, that the 20 is gonna be on this side of it. Thank you. If you're graphing it on a calculator or something, then you wouldn't need to do that, but I have my 20 right here. It's gonna be more than that. I think it's gonna be less than this and less than the other one too. And greater than 6. So I imagine that's gonna be like here. So it looks like we have that little bitty triangle. Is that right? I know that the x coordinates for two of them is it's going to be 20 comma something. 20 comma, oh, the first one is 20 comma 6, isn't it? And 20 comma, what is it? 24?
That usually plugging 20 into.
Yeah, I'm just either using this, or this is a horizontal line here at 6, so I do this 20 comma 6.
Yeah.
But for the other one, I had to use one that has a intercept of 4, so like my 20 to here. So for M. Didn't work out.
I know the other one has a y coordinate of 6.
That's on the same steep line as the 84, so in this case, I'll plug in 60, so 600, or divide everything by 100. The 78. 26 times.
26. And then whichever one of these you plug it in, it's going to be one of them will be the maximum. Which one is max? 26.6, 2024? The other one? Did anyone get it? $1.16 million for that first one. Is that right? 2.24. Am I getting that right? What's the last one?
0.4.
1.4. Okay, there we go. That's the most interest you're going to make by 20 million into the bonds and 24 into the mutual funds. Whew. Hope that made sense, folks. That's it for Unit 6. Next time, review, and then the party. Have a wonderful day, everybody. Yes, I definitely give it.